Let's look at how to solve a rational inequality algebraically. Once we do that, we then want to graph the solution set and express the solution in interval notation. Here's the rational inequality that I'm looking at, and just like when we were talking about a polynomial inequality, you want to make sure that everything is on the left-hand side and that it's either greater than or equal to 0. Luckily, that's what we have in this particular example. So we don't have to gather everything up. We can go down here and move directly into step number 2. Now, step number 2 asks me to solve the rational inequality for its roots, and in this particular case, I have to find asymptotes. So let's handle the roots. When we talk about the roots of my function, that's where we take the rational function 6 minus 2x and set it equal to 0. Okay, so I'm going to set it equal to 0 and solve. So when I multiply both sides by this denominator, I end up with really just 3x plus 5 equals 0. Subtract 5 and divide by 3, and I find out that I have a root occurring at negative 5/3. The next thing I want to talk about are the vertical asymptotes. Vertical asymptotes were where the denominator was equal to 0. So if I add 2x and then divide by 2, I get x is equal to 3. So this is an x-intercept. This is an asymptote. Those are important distinctions because I can include an x-intercept, but I cannot include an asymptote. So we're going to go through and we're going to set up our number line and pick test points just like we did before. Only this time, here at negative 5/3, I have a root. I usually write it above it because I could get confused sometimes pretty easily when I'm looking at these. And over here at 3, I have an asymptote. So when I write my inequality statements, or my interval statements, if I'm on the left of negative 5/3, I would be from negative 5/3, from negative infinity to negative 5/3. I have a parentheses on the left, but I have a bracket on the right because I can include the root according to my greater than or equal to symbol. In the center, I can include negative 5/3, but I cannot include 3 because it's an asymptote. On the right, I cannot include 3 because it's an asymptote, and I never get to the end of infinity, so that's why it has a parentheses. So I don't know, can you see how come I'm gonna make a note, or on my paper, that negative 5/3 is a root because it makes a difference, and 3 is an asymptote. Those things make a difference in how I set up my solutions. Now let's just go pick our points. To the left of negative 5/3, well, that would be what, 1 2/3. So to the left of that would be negative 2. In the center, the easiest one is just 0. To the right, let's pick 4. So those are the numbers that I am going to pick. I'm going to go ahead and write my function here again so we can see it. 3x plus 5, 6 minus 2x, and we're trying to find out where it's greater than or equal to 0. So I'm looking for values that would be positive if it's greater than. So when I test out negative 2 in my function, so I'm going to evaluate the function at negative 2, meaning I'm going to say 3 times negative 2 plus 5 divided by 6 minus 2 times negative 2. We're going to plug that whole thing in and simplify it. So this is negative 6 plus 1. Negative 6 plus 1 would be a negative 1. And this is 6 plus 4, which would be 10. So that's a negative value. Let's do the same thing when f is 0 and when f is 4. I think you can handle that. So if I were to replace 0 for x in the function, I would find out that in the center here, we're looking at positive values. And when I replace x with 4, I end up getting negative values. Make sure that when you replace those numbers on your own, you come up with negative, positive, and negative. Now I'm looking for, the question asks me, where is the rational function greater than 0? And the only place that that's occurring is here in the center position. So how would I write that? Well, I would write the interval solution so that it looks like negative 5/3 to 3 parentheses. And when I graph the solution set, those are the only two numbers that I'm concerned with. So negative 5/3, 3, I would put a bracket and a parentheses here, and I would shade in the center. And that's how you would go about solving a rational inequality.